This is 9.3.1, database and SQL injection. So first, we pronounce SQL as SQL in the computer world. So at the end of this lesson, we should be able to answer these guiding questions down here. How do databases work? And how is SQL coding language used to run certain databases? And also, what are the characteristics of SQL attacks and how might they be mitigated? What is a database? A database is a computer program that's designed to store lots of data in such a way that finding and retrieving any one piece is more efficient than it would have been if you simply dumped all of it into a file with no organization. So many industries use databases so that they can easily create reports, invoices, search results, and much, much more. So how is a database different from a spreadsheet like Google Sheets or Microsoft Excel? A database is just a spreadsheet on steroids. So both spreadsheets and databases use columns and rows to store data into nice, neat looking organized tables, but only spreadsheets store information in single tables with limited abilities to cross-reference or create reports. Whereas on the other hand, databases can cross-reference to extract data from multiple tables and rapidly produce many different types of reports. But remember that data is only valuable to us if it is accurate and if we have the means to analyze it in a timely and efficient manner. Let's talk about database structure. So here we have a database that we are going to call sport data. And it is a table with information in these columns: date, team, event, location, opponent, and score. So we as users can pull information from this database by asking questions like, what are the dates and teams playing in the semifinal games? Or list all the scores for events where the Cougars played. Obviously, there are many more combinations possible. So here's an example with school records. Your name appears in lots of different tables or lots of different spreadsheets. Okay, things like scheduling, what classes do you take, what times, what days, grades, attendance, name, ID numbers, PII, personally identifiable information. That's things like your social security number, your birthday, your health information, transportation routes, and your pickup locations and times, your sports team rosters, your coaches, your game dates, and locations. So, if we combine all of these spreadsheets to form one database, essentially, we're going to be able to create and run reports that ask really complex questions that we otherwise would not be able to answer unless we did some really, really complicated form of cross lookups against all of these different spreadsheets. But here are some of the reports that I could create if we put all of these spreadsheets into a database. Things like, what is the current math grade for any student wanting to take AP Calc next year that didn't have Mr. De Hoyos freshman year? Or run a report of all of the students who take the bus and are on sports teams that practice after school but are not failing their classes or something. Or list all of the students who earned honors and have perfect attendance for this grading period and separate them by graduation year. So lots and lots and lots of endless reports are able to be pulled when you stack a bunch of spreadsheets together to form a database. So again, SQL we pronounce as SQL. SQL stands for Structured Query Language, and SQL is a computer programming language that was created for database tasks like searching, updating, and extracting large amounts of data. A query is a method to get data from a database. So for a SQL database, the query must be structured according to the SQL language syntax. And the SQL syntax is right here. So using or referencing this syntax, here's an example. If we wanted the simplest SQL query, which is to ask for all of the data that's in a table, we would use the asterisk, which is us asking for everything. And this would be the syntax. Select asterisk denotes everything from sports data. This was the table that we saw in the previous slide. And you'll understand why there's a semicolon there in a second. So SQL database structure. A conditional SQL query is when the query pulls data only when the condition is met. So here's an example. I want dates and scores only from events that included the Bucks. If you've ever used like conditional formatting in Excel, kind of a similar concept. Attacking databases or SQL injection. SQL injection attacks involve adding conditional inputs that form true statements. So these are some special characters in SQL. We put a semicolon at the end of a query. We use tick marks to enclose strings of characters, but in SQL specifically, we use them to open and close query sections. We use quotation marks and parentheses to enclose different strings of characters. We use dashes, and this is not called a hashtag. This is called a pound sign. So we use the dash and the pound sign when anything after the dash or the pound sign is just going to be a comment. Like we're just writing a note to ourselves, and we don't want that to be interpreted as computer code. And then finally, we have our little star. We call that an asterisk. We call that the wildcard, which in SQL is used to represent everything, like in the example from the previous slide. SQL injection using true statements. So attackers use form input fields to create a query that will change the form function in a way that was not intended by the programmers. So testing a form for SQL injection vulnerability, it usually involves adding conditional inputs that form true statements. Here are some examples of that. This input will be taken by the program and then inserted into the existing SQL queries condition section. So here's the normal SQL query, and then the SQL injection input of a true statement will turn that query into this. SQL injection consequences. SQL injection exploits can result in bypassing authentication, unintended information disclosure like data breaches, data corruption, insertion of new records, changes to records, deleting records, or deleting entire groups of records, as in deleting entire tables.